Hey guys, it's Alexis Mitchell coming at you with an organic chemistry video. So today we're gonna go over my book, Learning Organics. Hey mom, what's organic chemistry? Good question. I'll show you my organic chem picture book. In order to understand bonds, we need to understand electrons. In order to get together, two atoms need to have eight electrons. This is called the octet rule. So then we have sodium chloride and cobalt 2 nitride. With sodium chloride, the Na has 1 electron to give to the Cl, who has 7, totaling 8. That makes a bond. We'll get to that later. To make cobalt nitride, 3 COs share their 2 electrons with the 2 Ns to make 2 pairs of 8 electron sets. There are some exceptions to the octet rule. They are hydrogen, which follows the zeroth rule, which only has 1 electron. Helium, lithium, and beryllium follow the duet rule, which has 2 electrons only. Boron has its own rule, and that is the sextet rule, which is only 8 electrons. Once the 4 rules are succeeded, covalent bonds can be made. What is a covalent bond? A covalent bond is 2 atoms that share valence electrons. So then this is the steps that would illustrate what a covalent bond is on a hydrogen gas. In hydrogen gas, the 2 atoms share their electrons with each other. The place where the electrons cross paths is where the covalent bond is formed, which is C. Another good example of bonds would be the compound methane, again illustrating where the bonds would go. In the bonding process, each hydrogen element contributes 1 electron to the 4 that carbon has. With 4 hydrogens, they succeed the octet rule, allowing covalent bonds to be formed. How does carbon have 4 valence electrons? In order to get 4 valence electrons, the electrons move energy levels. So this is how carbon starts off, because it's the 2 on the 2s and then the 2 on the 2p. And then it moves to be like this, 1 on the 2s and then 3 on the 2p. The carbon started by filling its s energy level, but in order to have 4 valence electrons, an electron is moved to the p level. You're probably wondering why there needs to be 4 electrons. Well, the answer is organic compounds. All organic compounds have a backbone of carbon. That means the main chain of the compound is carbon. Here's an example of an organic compound chain. I used octane, and we're just gonna Once a carbon has 4 electrons, it can be made into a chain. A chain is typically made of carbon and hydrogen. There can be other atoms attached to the carbons, but for the most part, we will be sticking with carbon and hydrogen. Furthermore, when there is a carbon, there is a hydrogen. When forming chains, there is a formula. And this is our wonderful formula. This means for every x carbons, there is 2x plus 2 hydrogens. Ignore the x, it should be an n. For example, and then I listed a few. I used C2H6, and then I did C6H14 and C10H22 just to show that there are differences. There isn't much of a difference between 2, 6, and 10 other than the amount of carbons. Oh my gosh, again. Another way to draw a carbon chain is as follows. So then I used C6 and C10 to show the Lewis structures. These are called Lewis structures. Wow. When drawing them, each line has 2 carbons, one at the beginning and one at the end. So then I drew out C6H14 to show where the carbons would go. It's almost like drawing out the compound only using the covalent bonds between the carbons. The hydrogens are just assumed, which is what we learned in class. So I used C7H16 just so I could show a different compound while showing the same properties, and then I just drew a different Lewis structure. Now that the carbon chains have been drawn, they need names. Each chain is named based on the number of carbons. So I gave this little chart. The longest carbon chain we'll be working with is 10. All chains with 1 or more single bond are called alkanes. Sometimes there are multiple ways to draw the same structure. Those are called isomers. Isomers can include chains that have branches. When a chain has a branch, it is named based on where the branch is on the chain. How do you name it? Here are some easy steps. Count how many carbons are in the main chain. Count from both sides. I made sure to include that one because we had two different colors. Second, determine which number of carbon each chain is on. Third, determine how many branches there are and what kind of branch it is. 4, name it. Let's try it out. So then I used those steps to create basically a walkthrough of how to name this one. So then I counted from both sides using 2 different colors to show the 2 different sides that I counted from. And then I labeled which were carbons, 236 and 256. And then I made sure to include the direction with the lowest carbon number wins. So in this case, it would be 236. How many branches and what kind of branches? Well, we have 3 methyl branches. And then when we name it, it goes 236 trimethylheptane. Here's an example of a chain and its isomers. So I used heptane, and then I included the, 2, 4, 6, 8 different isomers for it. Double bonds can also be formed. A structure with 1 or more double bonds is considered an alkene. Like single bonds, there's a formula to determine the number of hydrogens in accordance to the number of carbons. So then we have CnH2n, and then I drew out these 2 different ones. In order to make a double bond, the following steps need to be done. And then I listed the steps for the double bonds. I'm not going to read them this time. They're there. Have fun. Whee! Oops, let's fold it. Oh no, we have a fold. Okay, double bond. Oh, here we go. Here's an example. And then I used carbon dioxide to show the process of how to get to a double bond. And then since the electron chain charge is 0, this is the proper structure. I included the triple bond as well to show that there was an option to go beyond that, but it would leave you with a charge. When drawing the double bonds with Lewis structures, it's just 2 lines, all right? So I used ethene and propene, and when you draw them out, this is the 2 Lewis structures you get along with their carbon chains. There are also isomers for double bonds. When doing isomers, there are 2 types of isomers, the cis and trans. Cis means the same on both sides when split down the middle. Trans means the opposite on both sides when split. Isomers of butene, and I included these, including the cis and the trans on these 2, and then these 2 just being that they're themselves. All right. There can also be triple bonds. When there is 1 or more triple bond, it's called an alkyne. The formula for the number of hydrogens is CnH2n-2. And I also included ethine, and it's carbon and then Lewis structure. And propyne, same thing, carbon and then Lewis structure. Triple bond isomers of butane, I included these 2. And then I said triple bonds are just like double bonds, just an extra bond. There can only be triple bonds though, not 4 or 5 bonds on a structure. Yeah. That's organic chemistry in a nutshell. Wicked! The end. Alright guys, thanks for participating in my little organic chemistry video. Like and subscribe. Yeah, just to be clear, there's no broadcasting. These pencils are just there though.